Hello. Now, this video is about how to calculate the length of a line like this, because if it's a straight line, all you gotta do is like 1, 2, 3, 4, okay? So 1, 2, 3, 4, from here all the way to here, you have 4 units, whatever they are. Now, if it's a curved line like this, for example, just pretend this is y equals x squared. Okay, that means that y equals f of x, right? So what we're going to do is that this is like being close to the earth. The earth is a sphere, but because you're so close, it looks like a straight line. The floor looks like it's straight, okay? So what we're going to do is we're going to get a very small area infinitely close, okay? A very small area here, and we're going to zoom it out like this. This thing right here, when zoomed out, is going to look, let me put a square here, something that looks like a square. Okay, it'll go from here all the way to there like that. Kind of like that. It's just kind of, okay? Of course, it's not perfect. Let me try to do it one more time. Nah, not being able to do this smoothly. Okay, the smoothest I'll ever get. It's as smooth as I'll ever get. Okay, so let's just say that we get even closer. We get just this little part right here, right? And we zoom it out. Make the square here. Now this is a zoom of this area. It'll be even more straight, okay? It'll be something like that. So the curvature, as you get closer, is going to get smaller, right? Now, if you want to find out this entire length in here, what do you have to do? You see here, we're going to slice this thing up in vertical bars, okay? But these bars are going to be so thin, right? They're not going to be this thick in here. They're going to be like this, like almost impossible to see the space between them. So we're going to slice this thing, and we're going to walk 1 unit to the right. And how many units is it going to be up? Okay, well, you see, this, as we get infinitely closer, as we zoom in infinitely closer, just for that little part in there, this curved line is going to look like a straight line. So we can calculate it. If we consider this 1, because we're moving 1 step to the right, but 1 what? 1 micrometer, 1 centimeter, 1. It's 1 unit that's infinitely small, but you're going 1 unit to the right, okay? How much are you going to go up in here? And then you go like, oh, it's impossible to know because this is not a straight line, it's a curve. But as you get infinitely closer, this becomes infinitely, this starts to approach infinitely a straight line. So you can consider this a straight line. Now, what do we have in here? We have a right triangle, okay? With a right angle in here. So this is going to be 1. So we have a right triangle. Now I'm going to draw a right triangle like this, but I'm going to flip it. Okay. So this is going to be 1 because we're walking 1 to the right. How much does this go in here? Well, because this now can be considered a straight line. This thing is this thing here, okay? So because this can be considered a straight line, what can you do? You can take the rise over run. So this divided by this, okay, is just going to be what? The slope of the straight line. So you see that x divided by this divided by 1 is going to be, I'm not going to say x, I'm going to use c, okay, just so it's not going to confuse with this x in here. So c divided by 1, which is the rise over run, is what? Is the derivative of the function at that point, just at this small point in here, okay? or this small little area in here, which is part of this small little area. So because c divided by 1 equals the slope, c divided by 1 equals what? Equals c. All right? So can we calculate this thing here now? Yes, we can. So we know that this is going to be c. This is 1. All right? So what is the length of this stuff? It's this squared plus this squared. It'll be the square root, right, of this squared plus this squared. So it's going to be the square root of 1 squared, which is 1, plus the c squared. Well, what is the c squared? Well, c squared is equals c divided by 1 squared, which equals the first derivative squared of x. So we do this, right? What is the first derivative? It'll be dy dx. So we do dy dx squared. But this is just for this little part right here. What about for the next little part? Oh, well, all we have to do is sum it up. Sum all of them up. And we sum them all up. So what do? When you sum this formula for the first one and for the second bit, for this little thing here, and for this little thing, 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 and you keep walking here, okay? The length, what do you have? You have let's just say that this is 0. And this point right here is the point A. You have that the length of this curve is going to be the integral, okay, of the square root from 0 to A of 1 plus dy dx squared dx. That's it. And if you're integrating with respect to y, then analogously, all you gotta do is to invert the y with the x, okay? Let's just say that you're doing x equals f of y. Now, because the x is a function of y, okay, and y becomes the independent variable and x becomes the dependent. If it's this case in here, all you gotta do is integrate, okay, the square root of 1 plus dx dy squared dy. Why is it dx dy? Because now in here the dependent variable was y and the independent was x. So y varied as a function of x. In here you have x varying as a function of y. So it's not dy dx anymore, it's dx dy. Okay? And then you're going to vary the beginning value of y here and the end value of y here, whatever it is. Okay, the limits of integration. But instead of, let's just say that this is the case, if you have, I know it's a mess, but I don't want to erase this thing now, or maybe like this. I'm going to create some space in here. Okay. If this is the graph, and you have a function like, I don't know, it could be the same function, like this. But instead of having y as a function of x, we have x as a function of y. So we're not going to walk in steps of 1 to the right. What we're going to do is walk in steps of 1 up, okay, like this. So you're going 1 unit up, and how many units to the right? Well, if you have like this, right, let's just say that you have a straight line like this. So it's going to be 1 unit up. This is 1. Okay. And how much is it going to go to the right? Well, now it's not the rise over run. It's the run over rise. Let's just say that this is C now, or D. This is D. Okay. So what is going to be the slope? The slope of this straight line here is going to be run over rise. So it's D divided by 1, okay, which is just D. So we know that this thing here is D. And what is going to be the length of this thing here? Well, the length is going to be the square root of 1 plus d squared. But what is d squared? Is the run over the rise. So it's dx over dy squared. dy, because you're integrating going up, okay? In steps of 1 up, not in steps of 1 to the right. There's just something else that you gotta be very careful here. This is not the second derivative of x over y or y over x, okay? It's the square of the first derivative. So you see, now I'm gonna erase everything. dy dx squared is different from d squared of y dx squared. This is the second derivative to the first power. This is the first derivative to the second power. So what you want is this thing, okay? And we're going to do some exercises on the next video.